Hi everyone, welcome to my presentation, Building CLI Tools with Node.js. So why don't I jump right into my topic and we'll talk about CLI tools in Node.js. First of all, I'll open up my application here, Building CLI Tools in Node.js. So, a few months ago, I had to build a presentation for a Docker container presentation. And turns out that I wasn't really happy with my end result. I had to switch all the way between my PowerPoint presentation and my terminal. So I ended up pulling an all-nighter before the night of the conference, of course. And I actually came up with this idea of building a slide deck tool all inside my terminal window. And all of that was built with Node.js. So what I'm going to present to you today is pretty much how I built that tool by using that tool. So let me introduce myself and just get out of the way. There it is. So hi, my name is Joel. I work as a developer advocate for Red Hat OpenShift. We have a Kubernetes distribution for enterprise. If you ever have any questions about it, feel free to reach out to me. But this is not what I'm going to talk about today. I am based in Ottawa, Canada. And I'm French Canadian, so that's the charming little accent that you might have noticed there. And if you ever want to get in touch with me, I love Twitter. So feel free to reach out for any question, either about OpenShift or about building CLI tools in Node.js or just to say hi, just to say that you saw this presentation and that you enjoyed it, hopefully. Feel free to reach out on Twitter. Joel with 2 underscores Lord is the best way to reach me. And it's probably the worst Twitter handle ever. So 2 underscores there. But hey, it is what it is. Of course, I usually have stickers with me. So, of course, that's not very practical in the world of virtual conferences. But, one day we'll get back to online events and feel free to come and see me and I'll have a bunch of stickers on OpenShift and a bunch of other different things. Okay, so why would you want to build a CLI tool using Node.js? Let's talk about that for a second. So first of all, for me, it was all about familiar tooling and languages, familiar language and tooling. So I've been doing JavaScript for many years now, over 10 years. That's been my main language, and I'm comfortable using JavaScript. I have all the tooling available. I know all the libraries that I need. So it's very easy for me to just build something in JavaScript. Bash is hard, or kind of hard. I mean, it's not necessarily that it's hard, but I'm not as familiar with Bash. So whenever I need to run something, if I need to do file operation, or if I need to even do a for loop, I can never remember the syntax. I always have to Google everything. I end up finding something on Stack Overflow, which I just paste inside my script. So it's a little bit harder for me to use something like Bash. And of course, because I can, so why not, right? so that was the main reason why I ended up building this, pretty much just because I can. One of my challenges, a self-imposed challenge by building this slide deck, was to use only Node.js native modules. So I didn't want to add any additional libraries or anything else, just plain Node.js and JavaScript. So that was kind of my challenge here. And as I did that, I learned a bunch of different things all along the way. So this is kind of what I'm going to introduce you today. So there's a lot of examples of great CLI tools that are out in the wild that are available to you that you might have even used if you're a JavaScript developer. Create React App is a great example. I believe the Angular CLI and the Vue CLI are also built using Node.js. So those are tools that you've probably used if you are a front-end JavaScript developer. So those are built with Node.js. CLI slides, of course, shameless plug here. So if you're interested, cli-slides.com, or here's my GitHub repo, which is entirely built with Node.js. Dockly, great tool. If you have to manage Docker containers, Dockly is great. It's all built with Node.js, and it's much easier to use than the actual Docker command line. So you can definitely take a look at that one. That was built by Laurent Tal at Snyk. And finally, ipipe2, which is a great utility that you can use inside your terminal to pipe the content of one input or one output into another input. Great tool by Rui Adorno by NPM that you should definitely take a look at. All right, but you might wonder, where do I start, right? What is the first step if you want to build your own CLI tools so that you get published and get famous with that? The first thing you'll want to do is to provide some output, right? You'll want to provide your users with some sort of information. That's the whole point of having a tool. So showing something to your user, well, you can still use console logs, just like as usual inside any of your Node.js or even inside your JavaScript application inside your browser. But if you're using a Node.js application, you should probably start using process.stdout. It is a lot more powerful, and it lets you move your cursor around, use different colors. So it's kind of like a console log, but on steroids, right? As a matter of fact, console log uses process.stdout behind the scenes. So console log, the usage, you're probably familiar. You've probably tried to debug with it, although that's not the best way to debug, you know that. But you've probably used it already. So console log, just give it a string and it will output that string into your terminal. You can also use emojis. That's very trendy nowadays. A lot of CLI tools will have an emoji before each one of the lines, so you can kind of provide visual input to your users so they immediately see what's going wrong. So you'll have like a big X or a stop sign if something went wrong, or a little thumbs up if things are going well. So that kind of provides visual cues to your user. It can be very useful. If you're using emojis, just a small caveat here, you need to add more space. So add an additional space, so 2 spaces between your emoji and the rest of the string. Some terminals have an issue rendering them and they will overlap a little bit. That has to do with the way those are encoded. But the other way to use, to output to your users would be to use process.stdout.write. And then you provide it a string and it will simply write the content of that, or write that string into the standard output. So let's take a look at an example. So the first thing, I have a few examples here. Let me see, samples, there you go. So the first sample that I will run will be a node. And yes, I ended up building a terminal inside my slide deck that runs inside a terminal because I can. So the first example will be to run our console. So node samples console, and you can see that I just output hello world, and here's the second line. So if we take a look at what this file looks like, console.js, here it is. So it's just simply 2 console logs, one after the other, and we have the output. So that's kind of what we should expect, right? Now, if we run the standard out example, stdout, now you can see that there's a little difference here. Both of the 2 strings have been concatenated. If we look at the content of that file, stdout.js, you see that I have 2 process.stdout. So the console log would automatically add a new line at the end of each one of your characters, while standard out uses the current position of the cursor to end up writing. So that was very useful when I built this slide deck. As you can see right there in the bottom, I have the name of my company. I have different things at the top. I can output the different outputs from my terminal. So all of that is done by using standard out because I know where my cursor is at and I can position different things and I can center text. I can even make my application responsive if I'd like. Because yeah, that's good design, right? But yeah, you can do all of that because you know the position of your cursor and you can kind of manipulate that a little bit. There's an example that I can show you, and I'll need to open up a new terminal window, and I'll explain that in a few minutes. But now that you know how you can output directly to stdout, it's very easy to simulate different things. So you can kind of simulate someone typing, for example. So, you know, you can put some timeouts and it looks like someone is typing, but no, it's actually all a script, just, randomly making typos and backspaces and then taking time between each one of the keystrokes. So you can really manipulate and you can start doing a lot of different things once you start using stdout. You can also use colors, so you'll need to provide them with escape characters. \x1b is the character that you'll use for an ANSI sequence, and then you'll provide it a code. So 31M, if I recall correctly, is color red, and 0M resets the color to the terminal defaults. So you can start 31M colorizing in red, 7M, which will reverse the color, so it will make it black over white if you had white over black, and the opposite. So it just reverses the color of your terminal. You can change the background colors as well. So color codes in the 40s, so 43 in this case, will change it to yellow. and 0M will reset your terminal defaults. So let's take a look at another sample, colors. There we go. So using X1B code, you can change the color or even the background color. You can also change the cursor position, which I haven't shown in this specific example, but you can actually do it. You can move your around by using X1B once again, but then you specify the column, semicolon, the row that you want to move your cursor at. Or you can just use a number of rows A, which will move your cursor up. Move your cursor down, to the right, or to the left, so you can really move your cursor around by using those codes as well. And of course, there's a code to clear the screen, which is one of the code that I use each time I change slide. So every time I change the slide, I just clear the screen and redraw everything here. All right, so you've got some outputs. You can provide some feedback to your users. That's great, but you'll probably need some inputs as well. So to read user input, you can try to use stdin directly, but it's a little bit tricky. That your best friend here will be the readline module. So you can ask for free type input relatively easily by requiring readline, which is a native Node.js module, and then you'll create an interface. You'll specify what is your input and what is your output. So you'll use process stdin and process stdout. And then you can use the question method just to ask a question, and you'll have a callback with the answer, so you can actually process that answer. You can also use readline to process and trigger a key press event. That's very, very useful. So you can do something like create an interface, specify what is the input that you want to track, and then you'll tell stdin to emit a key press event every time a key is pressed. And then you have your event that you can use. So in my case, I'm looking for the right key and the left key so that I can actually move to the next slide or the previous slide based on the key that has been pressed. So once again, let's go here for another sample. I have something like this. Hey, what's your name? My name is Joel. Hello, Joel. Or I can say world, and I can get hello world. Perfect. And that sample, let's take a look at it. So once again, it's pretty much what I've just shown you. So just asking a question using the question method, and I can get that feedback and work on it. One slight little thing that you'll want to do as you get there, you want to use bash standards as well. So it's very important that you provide some output like the exit codes or the error codes. So whenever you want to terminate your application, use process.exit and provide it with an error code. That can be very useful. If I try to run this sample here, exit code. So you can see here this small script will randomly either complete successfully or create an error. So there's a 50-50% chance here. So let's see if I can actually get it. Still successful. Exit code, and of course 50-50 never ends up being 50-50 for some reason, right? But let's actually see it here. You can see that I have a prompt here that is a green arrow, and that's because the last command that I ran was successful. So if I run this sample again, you can see that it was successful. Oh, there it is. So I finally got an error. And you can see that I got an error code 1, and my prompt detected that I had an error, so I can immediately provide visual output to my user. So my user knows that something went wrong and the operation was not completed successfully. So you should use standards like that, which are part of the bash standards. Now you might wonder, how did I create that terminal inside that terminal? So that was done by running shell command. In order to run shell commands, you can use exec. That lets you run a command and parse the response. The callback, it will only be triggered after the command is processed. So I'll show you the example of typing in just a few seconds, and you'll see how it differs between exec and child process. So child process.spawn is also a way to create a new process, which will run in the background, but you can use the output from a stream to immediately show that on the screen. Starting to process those streams can be really tricky, so you might want to look into libraries like NodePty. Those will make your life a lot easier. So also make sure to watch for injections. That's very, very important. If you let people run commands on your machine, be careful on what you're actually gonna let the people run. So if I show you let me show you the example that I ran earlier about the one with the typing, right? Okay, so it started. So you remember it was typing one letter after the other, but now nothing is happening, and boom, there it is. So we've got a full content. So it waited until the operation was completed, and then the callback got triggered with the end result. So that's why I didn't show it earlier in my terminal here. So I managed to fix that by using the child process spawn, but then it gets really tricky on manipulating the stream and making sure that it displays within this tiny little window inside my window in a proper way. So that was kind of a something where I had to balance and end up choosing to go with exec in this case. But both are definitely usable. So you can also use Node terminal. Yeah, so this one will start a terminal. Oops. Node samples terminal. And this one starts a terminal inside the terminal inside the terminal. This gets really so let's just run it here. So that will actually run better. So we can see that it's waiting for any cursor input. I can type something like ls, and I get the result from the latest command, and I just output the content. So I can basically build a terminal inside the terminal right here. Exit won't work, of course, but yeah, so this is the sample. The other thing that I wanted to show you, just be really careful, because someone could come in and do something like that. You never know, right? So you have to make sure that you prevent those injections. So make sure that nobody can fool around with your machine. This actually came up from one of my friends, Ben DeCray, where I was at a conference and I was presenting, and you can see behind me that he actually went into and typed in RF on my machine because I had a terminal open. So make sure that you actually watch out for those injections and you do something about it. Now, the next thing that you'll want to do is to process some arguments. So you'll probably want your users to be able to provide you with some input directly as they invoke the command line instead of asking them questions, right? Just like most command line tools do. Tools like Docker will ask you for a bunch of parameters, Docker run, do something, kubectl to manage your Kubernetes cluster, kubectl, get, pods. So you give all the information inside one command and you just provide the output. So processing arguments can be done. You can process arguments by using process.argv, and parsing them though is a whole different game. So that's where it gets a little bit more complex. So you probably want to look into a library. I was really stubborn and I didn't want to use additional libraries. In the case of this application, it's not that bad because I take only one argument, and it's the name of the JSON file that I parse to display those files. So you can use a process.argv. It will just output the arguments that were passed. So we can use our sample here, arguments. And you can see that the first one is the executable and the path to the executable. The second one is the actual file that I invoked. And if I samples.arguments and I say, well, we'll use file-f, output.json, -o will be JSON format, -- something. So you can put in a lot of different arguments, but you can see now that I'm only getting each one individually. So if I need to know what is the value that was passed to the F flag, it gets really tricky. As a matter of fact, I did a small attempt at processing those. So this one was called processed, and we'll say -f output .json, -o JSON, something. And you can see that I can kind of parse some of them. There's a little bug here, but it kind of works. But if I let's just open up that file. You can see here that it took me 30 lines just to manage to parse that, and it's really buggy. So you'll probably want to use a library to help you there. All right, another thing that you might want to do if you're using a Node.js for CLI tools is interacting with the file system. So using FS, which is a native module, you can interact with the file system. Any sort of manipulation, including file watching, can be done through this module. So reading from a file require the FS module, read file, provide it with the name of the file, and you have a callback that you can use to process the data. Write file works in a very similar fashion. So name of the file, the content that you want to write, and there's a callback that is called once the operation is completed. Now, those work well, they work very well, but there's a good chance that if you write and you read immediately afterwards, that you won't get the final file that was just written to. And that is because write and read are synchronous, or asynchronous, sorry. Now, what you might want to do in some cases is to use the synchronous function. In the case of my CLI slides, I use the synchronous because as I open up the application, I know that it's going to take just a few milliseconds to get that JSON file, and I want that JSON file before I do anything else anyways. So it makes sense to use sync in some cases, it doesn't in other cases, so it really depends on what you want to do. If you have a sync, then you won't have a callback, but you will it will return the result of the read file, and the write sync will just pause the execution until the operation is completed. If you want to use a promissified version, you can write your own. So you'll actually there is not one that is part of the Node.js core already, but you can just use it by using a native promise and use the read file and resolve that promise in the callback. Once you have that, you can then use it then and process the data from your file. Another very interesting thing that you can do with the file system is to actually watch different files. So you can actually watch a file for change. So I've seen that many times. There's a lot of build tools in Node.js that actually use that feature. So they're watching for files. NodeMon, for example, which you might have used if you built Node.js application, will watch for any file and restart your Node.js file or script once it detects a change. So I had seen that many times, but it turns out that it's actually a lot easier than I thought it was. So just use the watch function, give it the file name or the files that you want to watch, and then a callback to do something whenever it changes. So actually, if I go back to, let me just open up my source code here, and I'll go to my Node CLI, and oops, back to code. It's somewhere around here. All right, watch a file. So say I want to change from blue to yellow. I save this, and you'll see in a few seconds, and boom! There's the magic. So it immediately changed it, or almost immediately. So that's very convenient if you're building a tool like this one and you want to be able to track the change. So I can actually write my slide text, see the result immediately, change a few little things in my slide, and see the output. So adding file watch can be very useful. Reading and writing from files, let's actually run those here. Samples, and we'll do a write file. So argument missing. So you can see here how I check for arguments. There was none, so I've returned an emoji and I've returned an error code. So let's run this again with a world. Successfully wrote to file, so that's good. And now I can use node sample/read file. And there it is. So we've got hello world. So what happened here? Actually, let's just do a cat here. Samples write file. Check for arguments, and then it simply wrote to the file. And once it was done, it just outputted a success message. And the read file uses the promissified version. So cat samples/read file. And you can see that it uses the read file promissified. So it reads the file hello.txt, gets the data, transforms that into a string, and then console log the content of the file. Good. Moving on, packaging and publishing. So finally, you've got this tool. It is awesome. You want to publish it for the whole world to be able to use and benefit from it, right? So people will want to download that, will want to install it on their machine. So how can you do that? Well, you can deploy your application to NPM. That's the easiest way, and then the rest of the world can actually enjoy it. You'll need to do a few little changes on your package.json file, though. So first of all, you'll need to add a shebang character sequence to your JS file. So you'll need to add this sequence here. So just tell bash or whatever shell that you're using, what is the executable to be used with the script. And then you can make that file an executable, and you'll be able to run this file as if it was just another shell script. The other thing that you'll want to do is to add this bin here inside your package.json, and you'll just give it the name of the executable inside your system. So you saw when I typed CLI slides when I started, so that's the name of the executable. And you tell it what file inside your package that this maps to. So in my case, it maps to presenter.js. So if I would type node presenter.js, it would be the exact same as just running CLI slides. So what this does is that when you'll run an npm install, it will actually create a symlink so that when you type CLI slides, it just runs npm presenter.js. If you're developing your own CLI tools, then you'll want to use npm link, so it will manually create that symlink for you. And once you're done, you can use npm login to log into your account, and then npm publish, and this will publish your module to npm. All right, so that's all you need. So by using those simple APIs, you can build powerful CLI applications. This whole presentation deck was built with no dependencies whatsoever, as I mentioned. But there are some tools that you might want to use as you're building your applications. Oak Cliff is the open CLI framework. I believe it's available on NPM. You can use it with NPX. It will help you to create pretty much everything that you need to build CLI tools. So single commands, multi-commands, all the scaffolding, linting, packaging, testing, everything, processing the arguments, everything that you need can be done immediately. So it provides you with a scaffold to build your CLI tools. Yarg's great library to parse arguments. It makes it much more easy, handles short or long types, handles flags, arguments, a lot of different things. Chalk, which is a way to colorize the text. So instead of remember those ANSI sequences, you can colorize the text. It can move the cursor around, can do little things. I thought that the syntax was awkward, so what I ended up doing is just the parsing. So I have a write function that uses process std out write, but I just replace the color codes or the name of the colors in square brackets with the actual ANSI code. So I don't have to remember the codes, and I can just use those brackets. So you saw how I had yellow and I changed it to blue. So that's kind of what I ended up doing. NodePty, great tool to emulate the terminal. This is what is used in Xterm. So if you've ever seen terminal inside a front-end application, Hyperterminal, which is a terminal that is built in Electron, or VS Code. VS Code also has, where is it? A terminal that you can use. So right here. And this is all using NodePty behind the scenes. You can set the height and width of the pseudo terminal. So that is what I would need for my terminal inside a terminal, so that I could manage to get the content just to fit inside that little window. So in summary, to display anything, std out to any input, std in. Parsing arguments is hard, but process.argv, definitely doable. Full access to the file system through fs npm to publish just like any other library, and use Oak Cliff, Yargs, Chalk, NodePty, and a lot of different libraries just to make your life easier. I'll leave you with a few links. Make sure that you take a look at the Node.js documentation. It is awesome, and there's a lot of things that you might not know are there. So that's actually how I discovered the watch function. Definitely take a look. Creating Node.js CLI packages, there's a link for a blog post here on how to publish all of your CLI packages, and all the escape codes in the terminal are available. All those links and a lot more available on easyurl to CLI. And if you have any questions, reach out on Twitter, Joel__Lord. Thank you.